Hi guys, we are going to be going over 13.5, which has to do with independent and dependent events in probability. So compound events or two or more simple events happening together at the same time can either be independent or dependent of each other. So they may impact each other or influence each other, or they could just be two things happening at the same time that have nothing to do with each other. So for these events, and I forgot to plug in my microphone, so that this will sound at least a little bit better. Hold please. There we go. Events that are independent of the probability, events are independent if the probability of one event does not affect or impact the probability of the other. So choosing a red ball out of a bag of blue and red balls has no impact on choosing an apple out of a basket of apples and oranges. They don't change, like they're completely separate things that are occurring, so they don't impact or affect each other. Events that are dependent, events are dependent if one event in some way changes the probability that the other occurs. So one is impacting or is dependent upon the result of the first event. So some of this will look really confusing once we work on it with actual problems. It'll help out a little bit. But for events that are independent of each other, you're just going to take those two probabilities and multiply them together. That is all. You just multiply those two things together. If they are dependent, then you're going to take that first event and then you're going to have to figure out that second event because of that first event. That's why it says B/A. It's telling you that those are dependent, that event B may be impacted by event A and that result, and then we will multiply them together. The probability of B because of A is the conditional probability, and it is read the probability that event B occurs, giving that event A has already occurred. This is saying the events of, or the results, I should say, the results of event A have an impact or effect on event B. So event B can't really happen until event A happens. So we're going to look at some different situations and decide, are these independent? Do they impact each other? Or are they two separate events that we find their probabilities separately? So our first example here says, our probability question is 10 red and 8 blue marbles are in a bag. Suppose Josh draws a marble, not liking the outcome, he puts it back and draws a second time. What is the probability that on each draw his marble is blue? So this is very important. The key word here is that he puts it back. He puts the marble back in the bag. So with that first draw, we're going to say draw 1. The probability that it is blue, there's a total of 8 blue marbles out of a total of, 8 blue marbles over a total of 18 marbles in the bag. If I reduce this, those are both divisible by 2. We get 4/9. Now, if he kept the marble out of the bag, that changes the total number of marbles in the bag. Our number of marbles in the bag would turn into 17 because he kept a marble. But since he put it back, for our draw 2, there is still a total of 18 marbles in the bag. And If he picks another blue one, it's still 8 out of 18 because he did not keep that blue marble separate. He kept that marble and he didn't keep the marble, he put it back in the bag. And so our probability ends up being the exact same for both events, 4/9. So the probability that these both occur, so P parentheses A and B, that these are both occurring, that means we're going to multiply these two probabilities together. So 4/9 times 4/9. You multiply across and you get 16/81. 16/81. So if he is putting it back, it doesn't change the total outcomes. And so it's going to be independent. I'm going to put an I for independent. So it does not impact the second draw at all. Now let's look at another one so you can see what a dependent one might look like. Scroll. There we go. So this question says, what is the probability that a red marble is drawn from a bag of 2 blue and 4 red marbles, not replaced, then a second red marble is drawn? So for our draw 1, our total, we have 6 marbles. I should put total on the bottom. And the first one is red. Woo. So there's 4 red. For draw 2, we have to think about if they did not put the marble back, our total number of marbles is no longer 6, it's now 5. And they kept a red marble, so my total number of marbles, or total number of red marbles, is no longer 4, it is now 3. So because of this, it is dependent, because that second draw, the total number of outcomes changes because of the first draw. Originally, we had a total of 6 marbles in the bag. Because they did not put the marble back, there's now only 5. I'm going to go ahead and reduce this 4/6 to 2/3. And so our probability is going to be probability of A times the probability of B after A. That's 2/3 times 3/5. Multiply that across and you get 6/15. But we can reduce this and get 2/3.